Hello, and thank you for joining us today as we talk about simplifying and securing the heterogeneous data center. This webinar is brought to you by Actual Tech Media and Stratoscale. My name is Scott D. Lowe. I'm a vExpert. I'm also the co-founder of Actual Tech Media and a consultant, blogger, and author. I'm joined today by Jeff Margolis, who's the Director of Pre-Sales Engineering for Stratoscale. Thank you, Jeff, for joining us. Why are we where we are today in the data center? First of all, the data center has become a very complex place. It's far too expensive to manage, and it's really become a hindrance for the business. In fact, because of the complexity and cost of the data center, in many instances, the business is actively held back. We have a lack of flexibility and agility that can affect how the business is allowed to move forward, and it's always a challenge, not always, but it's often a challenge today, that we simply need to find ways to overcome. This is not what IT is supposed to be about. IT is supposed to enable the business, help it move forward, not hinder it from doing so. There are a number of needs that we see in the modern data center that we don't always have. We have a need for hardware heterogeneity. We want to deploy what is needed when it's needed, and where it's needed actually. We want to enable deep levels of abstraction so we can do what we're supposed to do. That is, that by abstracting more, we're able to better manage the resources that we have at our disposal. The layers of abstraction that we have in the data center today, for example, virtualization, have allowed us to commoditize the compute layer. It really doesn't matter what the underlying hardware is anymore, as long as it has enough beef to be able to get the job done. The virtualization layer actually does all the heavy lifting today. It presents workloads to the users. It does all that stuff that would have been done by physical resources back in the day. When we think about it, though, virtualization itself was supposed to fully cut the hardware cord, any vendor, any time. That hasn't always happened, though. We have been able to do that on the server side, but we still have challenges around networking and storage that we need to overcome. When we look at the world of hyperconverged infrastructure, which is the melding of compute, storage, and easier management, that's in some ways really exacerbated the problem of this heterogeneity issue. Many vendors require specific hardware configurations. So when you buy something from another hyperconverged infrastructure vendor, you're having to buy a pre-built appliance that meets their specifications. This is not necessarily a bad thing. Some organizations want to do that, and it's perfectly fine. But it doesn't provide the full and complete level of flexibility that's demanded by many enterprises and many organizations. There are other solutions that may require forklift replacement. So if we're looking at the data center, we don't really want to have to do that. That's one of the things we're trying to avoid, because doing a forklift replacement is expensive, time-consuming, and really has a high level of risk associated with it. When we look at modern data center needs, some companies truly want a set-it-and-forget-it hyperconverged solution. They want to put boxes in the data center, and they want to walk away and close the door and throw away the key. That's fine. There's choice out there for everyone. But other organizations really want and need far more granular control over individual resources in the data center. This idea of set it and forget it doesn't sit well. They really want to be able to interact with the data center, but in a way that's a little bit different than what they do today. They don't want the complexity they have today, but they still want the kind of control that they need. So when we start talking about heterogeneous hardware, we think about this whole idea of bring your own. We went through the bring your own device thing a few years ago. Now we're talking about bring your own hardware to the data center, BYOH. This allows us to leverage existing hardware, for example. You don't have to throw away perfectly good equipment. You can actually turn that equipment into a hyperconverged powerhouse. And we can get exacting with resources, which allows us to reduce sunk costs. We don't have to buy more than we need. We think about how we've bought the data center in recent years, and we've really done that on a 3 to 5 year replacement cycle. And we've thought about what we need for years from now, not just about what we need for today. We need to think about a just-in-time data center mentality. So we build and buy what we need when we need it, not 3 to 5 years out. We want extreme abstraction. The data center hardware is really becoming plumbing. In fact, if you think about your house, you don't really care about the pipes behind the walls. You only care about them when they break, and then bad things happen. What you really care about is the water coming out of the faucet. As long as the water's coming out of the faucet, you don't care about the plumbing, nor should you have to. And when you have a problem with your pipes, you simply call a plumber in to do the job, he fixes it, and then he leaves. You don't have a plumber on staff in your house. And you shouldn't have to. The outcome is what we're interested in. In this case, it's the business applications. We want to abstract as much as we can so that we're able to make things simpler and deploy things faster and have a better overall economic model for the data center. Let's think about the network for a minute, though. When we think about most hyperconverged solutions on the market, the network really is a separate entity. We're plugging into the network, we're consuming the network, but we're not necessarily actively managing the network. We think about those solutions, and they've done a great job at combining compute and storage, but again, the network is sort of an afterthought, and it's basically using what's already built into the existing hypervisors to manage network resources. So some hypervisor networking features are retained, but it's not transformational for the network resource the way the hyperconverged has been for compute and storage. We're consuming the network, we're not doing anything else with it. We have missed a lot of networking needs. We have a need for security, multi-tenancy, and workload isolation. We don't always have the ability to do that with hyperconverged solutions that exist on the market right now. We have a need to have a way to enable these kinds of outcomes and still have the management ease that we've had with hyperconverged infrastructure. As companies grow, this becomes far more important. You may want to be able to actively separate or segregate business units from one another in the infrastructure. For service providers, enabling multi-tenancy is absolutely critical. We can't have customers commingling their workloads. Only bad things can come from that. So when we start thinking about hyperconvergence moving up the market, these kinds of things are going to continue to become increasingly important over time, and it's something that the hyperconverged vendors of the world are going to have to face. It really all comes down to ensuring security and performance. We have to have a deep level of understanding of I/O patterns and pathways so we can avoid interference, and also so that we can bring resources to bear when they're needed. So if an application needs more network or it needs more disk, we can bring those resources to bear because we have a deep understanding of everything that's happening in the environment. When we have a separate hypervisor from a third party, or we're not fully managing the network layer, we can't get as deep as we need to, and we can't absolutely guarantee quality of service for applications. Let's think about the network a little bit further. We talk about this idea of software-defined networking. I'm not going to get into exactly what software-defined networking is, but we think about wanting to move to this software-defined paradigm for every resource in the data center. Now, hyperconvergence is not yet taking on software-defined networking. However, I think it will at some point. But some networking needs remain critical to manage within the confines of a hyperconverged cluster. We really have to be able to fully understand and manage all the networking that's happening inside the cluster. That doesn't mean that we have to have control of edge devices yet. We want to worry about what's in the brains, in the data center, and we can worry about the edge later on. Maybe someday we will see hyperconverged solutions talking directly to software-defined networking devices. We're not there quite yet, but we still need solutions that can assimilate the network from inside the hyperconverged cluster and do wonderful things with it. Let's also talk about DevOps. We think about this, we've heard this buzzword for a long time, and this is basically, a development operation sort of becoming a single team, or at least a single mentality. And we see a lot of data center environments that are not really designed for this paradigm. We have slow provision and we have separate environments, so we don't have really alignment or cohesion between those two groups. DevOps requires very fast auto-provisioning of resources so we can have a rapid, iterative development process. This is the way that development happens today. We want to know it's going to work in production, and we want to know that our teams are aligned. So we have development that are creating the programs, and we have operations that's managing them, all working together towards these goals. In order to get to true DevOps, we have to have constant and granular resource monitoring. We have to understand exactly how applications are performing, so we have an expectation of how they're going to perform once they actually hit production, and we know where the bottlenecks are going to be. In a perfect world, a hyperconverged vendor would own everything. They'd own the network, they'd own their storage, they'd own the compute, they'd own the hypervisor. Everything would be organically built into the solution, so there'd be no poorly integrated bolt-on services that we can't fully leverage. We'd have full and complete centralized management for all cluster resources, including that internal networking that I talked about just a minute ago. And with all that in mind, I'd like to turn it over to Jeff Margolis from Stratoscale. Take it away, Jeff.
All right, thank you very much. And I've got access to controlling the slides. All right, so as I've sort of developed some of these slides, we talk about where customers are on the sort of what I would call cloud timeline. So the majority has sort of gotten to the place where they're in the virtualization environment. So they've moved around standardization and consolidation and so forth, and now they're getting to the point where they're lowering costs and increasing utilization and flexibility. It's sort of the next stage that customers are trying to get to is more towards automation and orchestration. I think you touched on this very well when you're talking about sort of this so-called DevOps environment, where DevOps basically states that we're going to cut down the middleman as it pertains to launching systems, and that's tons of VMs and containers. Containers are very nice for deploying applications, very simple from a coding perspective to deploy applications, and as well as utilizing a disparate hardware in the same cluster. Again, these are things that now make the clusters easier to deal with and easier to manage than your typical virtualization environments. So it's more dynamically aligned for demand, and this is for the consumption devices that are our phones and tablets and watches and computers and so on and so forth, and we're reducing complexity of, I need this specific configuration, Scott, that you sort of spoke to. It has to be this specific server, this specific network adapter, and this specific fiber channel, and so on and so forth. All these things can now be mixed and matched in a Stratoscale provided cluster. And a lot of HyperConvergence is gearing towards that, but they're hardware anti-agnostic, meaning that they're appliance approached, and those don't lower your cost or improve your experience or your speed to market necessarily. So we're transforming the infrastructure here at Stratoscale, where we're allowing virtual machines and containers to be on the same disparate hardware. We're talking about depreciated hardware as a way to commingle with brand new hardware, which gives us the capability to do intelligent resource management. This allows us to move workloads around based on what a server can handle and what the workload demands. And this is all back-ended by a high-performance storage protocol that Stratoscale developed in-house, and is very robust, highly available, very strong, nicely distributed, and so forth. And this is all utilizing the disks inside of the servers that participate in the Stratoscale cluster. So are you as a user and customer using any kind of virtualization environment? Sure you are. You're probably using it all the time. Is it convergence or is it integration? So I consider most of the people who are claiming hyperconvergence today are really just doing integration, which is, it's fine, but it's not getting you to the place where compute, network, and storage are all being handled by the same software. It's usually software that is doing different components, but they're not driven by single APIs, or they're really just integrating VMware or Hyper-V and calling it a hyper-converged environment. That's integration versus hyper-convergence. So you're looking for a single vendor solution because you don't want to bundle disparate technologies. You don't want to have different hardware silos or software silos. You don't want competing resources. You want to reduce your path of access. You want to just be able to, boom, launch 100 VMs instantaneously, and that makes life a lot easier. And you want a unified management stack and not having to go out and buy little discrete pieces of software to do every little piece of management, or try and spend more money just to get a single job done. So how are those server resources managed? It's disaggregation. What that means is that we're doing real-time physical resource and workload usage awareness, and intelligent workload characterization and placement logic. So a lot of very nice words there, but what does that mean? Again, we know what CPUs, what memory, what disk, what network, what is being used inside of a cluster, and we know how to move those specific workloads, whether they be VMs or containers, around to different parts of a Stratoscale cluster that would be best served to make sure that all of the resources are available as necessary and as available. So this is sort of where hyperconvergence meets hyperintelligent. We have tons of algorithms and measurements and capabilities and products that we use to make a very nice single distribution that you can install in your cluster. So it's dynamic cluster management, fine-tuned storage-aware KVM hypervisor. So we re-engineered KVM so that it's a lot better than it would be just straight out of a standard Linux distribution. We're using components of OpenStack, a distributed block storage device, a hardened operating system based on Linux, a very nice single and centralized management UI that doesn't require a heavy executable to be installed on a Windows box, but can be used on phones, tablets, Mac, Linux, Windows, doesn't matter. A very simple CLI that even I, as a pre-sales engineer, can use very nicely. A RESTful API to deploy your applications, your volumes, your tenants, your users, your network, your storage through Python or Java or whatever you'd like, using our APIs to consume all of those capabilities. And we have relevant OpenStack bindings and API support. So if you're buying any third-party appliances like virtual appliances or software that you want that utilize OpenStack APIs, we support that very nicely out of the box. So the sort of 5 pillars for a Stratoscale operating system, these are our technical value propositions. HyperConvergence by a software distribution, so you're not bringing in Linux, you're not bringing in VMware, you're not bringing in Windows to be the base operating system on the servers. We're providing the entire distribution as a downloadable ISO that installs the same installer on every single node. So as an OpenStack deployment, you don't have to do a topology design of this is where my storage node is, this is where my Horizon node is, this is where my storage management system is, this is where, you know, so on and so forth. Every server gets the exact same installation and participates in storage, networking, management, and compute. And again, you can mix and match any Sandy Bridge Intel processor or newer. Our PCLM, or post-copy live migration technology, again, is the way that we're able to move workloads around the cluster to make sure that they're being utilized the best capable physical server as possible. So strong workloads are on a new processor. Less taxing workloads are going on older processors if you mix and match hardware. And then when we move those workloads around, we can move from source to destination about a half a second on average. A distributed high-performance storage protocol that's using all the disks inside the server. So if you have 10 servers and 10 disks, you have 100 disks, as I like to say, in a single block storage device. We have tiering and deduplication and all these different sort of thin provisioning techniques and so forth, and highly available data. So we're doing this very nicely in terms of a storage protocol that is inside the cluster, so you're not spending money on expensive fiber channel or iSCSI or NFS systems. Single fully distributed management plane, so all the management processes and state are replicated to every node in the cluster, so resources are not wasted on a single management node. And again, feature-rich API-driven control plane. So again, bring your own hardware, Sandy Bridge Intel processors and newer, mix and match hardware, new and old in the same cluster, blades, 1U, 2U, quads, twins. They all work in the same cluster very nicely as long as they're based on Intel x86. They're Sandy Bridge or newer, so no Nehalem or Westmere, all Sandy Bridge, Ivy Bridge, Haswell, Broadwell, whatever. Utilizing all the resources inside the node, so no external storage required, no external management systems, no complex network topology is needed. A single installer for every node, and we can scale to hundreds or even thousands of nodes in a single Stratoscale cluster, which basically means that you don't have to use a specific node to be management. And when I say hundreds or thousands of nodes, you can grow beyond the 32 or 64 nodes that other virtualization would limit you per cluster. So again, bring your own disks, your own capacity, so you could do SSDs and hard drives, SAS and SATA, all in the mix, PCI, flash, whatever you'd like to, different types of performance, different types of capabilities, and all put those into sort of a heterogeneous but very nicely performing single blob of a cluster that will give you all the compute capacity and performance that you would require. So our Mancala storage protocol is sort of working as you see on this picture here. All of the servers are given a big block storage device that are based on using all the disks in a single pool. All of the VMs are using a standard VirtIO driver, and the containers are doing the same thing. They're speaking to the Mancala client, and the client speaks to the server is speaking to all the disks, and this is protocol-less meaning it's not using iSCSI or Fiber Channel or NFS or whatever. This is all just moving data buffers from VM to disk back and forth, so extremely fast. Management is fully distributed, so again, securing how your data center is going to be super highly available as possible. All of the processes that are required to run the cluster are in a self-healing sort of design, which means that all the processes are running active or dormant and can read from a state database if required to be called up upon to continue on. So whether it's an unplanned or planned outage, those dormant processes can turn on instantaneously, read the state of the cluster, and then continue on, making sure that you have a highly available cluster. So what are we providing? Software, freedom for you to choose all of your own hardware, and it's not appliance-based and it's not expensive like the appliance-based solutions. Mix and match your processors and configuration. It's a complete stack, and all you need to do is stand up your environment. Each node takes just a few minutes to get up and running, fully join the cluster, and be ready to run compute. So from install to compute and operation is very, very short period of time. We're bringing infrastructure and intelligence, and it's a globally distributed management plane. And thank you, and Scott, I will turn it back to you.
Thank you very much, Jeff, and thank you all for joining us today.